Hi, welcome back. So today we're going to talk about the difference between linear and nonlinear functions. And we've worked with linear functions before in our last chapter when we talked about graphing linear functions. Sorry for the cat interrupting, but so we were talking about linear functions. We graphed them in our last chapter. And so that was when we were working with the form y equals mx plus b. And so we're going to talk about how to know if we have a linear function versus a nonlinear function. So let's start with what is a linear function. So a linear function is a function that has a constant rate of change. So that's our slope. And its graph is a straight line. So that was what we were, in chapter 5, we were graphing that y equals mx plus b, and it created a straight line. So any of those relations that creates a straight line. A non-linear function is a function that, does not have a constant rate of change, and the graph is not a straight line. So we're going to first, in this first video, we're going to look at how can I tell the difference looking at their graphs. So, considering the following set of ordered pairs, I've already gone through and labeled mine. So I did my x values by 2. And my y values by 1. And so I'm going to start graphing. We have a point at 2, 1. Maybe if it will graph. We have a point at 5, so that'd be halfway between 4 and 6, 3. So 1, 2, 3. We have a point at 8, 5. And we have a point at 11, so halfway between 10 and 12, 7. 6, 7. And so when we look at these, our points create a line. And another way I can look at it is, I know that if I do 3 minus 1, that's going to give us a difference of 2. And 5 minus 2 is a difference of 3. And so that's a slope of 2 over 3. And if I do 5 minus 3, I have 2. And if I do 8 minus 5, that's a difference of 3. And same here, 7 minus 5 is 2. And 11 minus 8 is 3. And so all of these has a constant rate of change of 2/3. But when I'm looking at this graph, what I notice is that they create, and I'm drawing the best that I can, a straight line. All right, so let's look at the next one. So here's our second graph. And if you notice, when we talk about straight line, we're meaning straight, like a line is straight. So this is what we call a curve. And technically this is a quadratic, but notice that it is curved. It's not a straight line. This is not a constant rate of change. All right? Where it is a function, because for every x value there is only one y value, we don't have that constant rate of change or a slope. And so this is a non-linear function. So let's get some practice in. Graph the set of ordered pairs and determine if it represents a linear function. If it does, find the rate of change. So I'm looking at these. Our y's can go by, or our x's can go by 1s, 2, 3, 4, 6, 7, 8, 9, 10. And because we have to get to 13, I'm going to do our y's by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, So graphing these, 1, 5, so halfway between the 4 and the 6. 2, 7, so halfway between the 6 and the 8. 3, 9. 4, 11. 5, 13. And so when I look at these, they're making a pretty good straight line. So I'm going to say that this is linear. And then it tells us to find the rate of change. Well, the easiest way to find the rate of change is to pick 2 of our points and to simplify, do y minus y, right? And I always do the second minus the first. So 7 minus 5 is 2. And so I'm going to double check that all the way through here. 9 minus 7 is 2. 11 minus 9 is 2, and 13 minus 11 is 2. And then I'm going to do that with the x's. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. And so since this is a constant rate, our rate of change would be y over x, right? So we're going to do 2 over 1. Which equals 2. And so our rate of change is 2. All right, next one. Identify whether each graph is a linear function or a nonlinear function. So looking at this first one, we're rising from left to right. It's creating a line, and so this one would be linear. And if you need help remembering, linear has the word line in it. So does nonlinear, but non means not. All right, next one. This does not create a line. This is a curve, so this would be non-linear. In our next one, maybe. There we go. On this one, yes, the sides of each of these sides creates this straight ray, but this is linear because it's at that constant rate all the way through, whereas this one we have a positive rate and a negative rate. And so this isn't a constant rate of change. And so this is not considered a linear function. This would be a nonlinear function because it's not just one line. All right, so that is it for our first video. In the second video, we're going to talk about, well, how can I tell if it's linear or nonlinear given a table? So I'll see you there.